Welcome to an episode of Keymasters. I'm the host, Sven Rajala, and today we've got Tomas joining us, and we want to talk about some post-quantum algorithms. So Thomas, we know that NIST is getting ready to finalize the NIST algorithms, and we've got Sphinx Plus coming, dilithium, and Kyber. But what do we really need out of those? Do I need all of them? Do I need maybe just dilithium? Like, what's my strategy going to be with these?
Probably, what level do you want to take it on? I'm thinking that, we shouldn't do it for, talk about it like for cryptographers, right? Because I'm not a cryptographer. And if you're a cryptographer, you're probably reading the spec and know everything about it. So.
Yeah, that's a good point. We'll keep it higher level then.
Good, dumb it down so I can understand it. So basically, to keep it simple, we can focus on the two primary ones, Kyber and dilithium, because they kind of show the concepts of the algorithms. And it's, of course, it's easier to compare with, what we're using today.
So like RSA and elliptic curve?
Exactly.
Okay.
Of course, today everyone, RSA is our Swiss Army knife of asymmetric cryptography.
Yeah, long-time user, 17 years here.
Yeah, it's a remarkably flexible algorithm. You can do anything with it. You can do block encryption, you can do digital signatures, so that you use it for key exchange, encrypting messages, digital signing documents or code or anything. You can do that with RSA. While elliptic curve cryptography is a bit more limited, that you mainly use for digital signatures. So authentication, you sign to prove that you're you, or you sign a document to see that you signed it and hasn't been changed in transport somewhere.
And the key sizes are probably a lot smaller. I'd take it with elliptic curve.
Yeah, exactly. And one of the benefits of elliptic curve is that the keys are small, the signatures are small, so it's been very popular with constrained devices like IoT.
I was just going to ask, IoT is probably a big use case for that, yeah.
But also even TLS, connections where you want to send less bytes over the wire and everything like that. So if we try to
compare that to the we'll say traditionals to the new guys on the street.
Yeah, and the new guys, if we say Kyber and dilithium, so there's nothing that compares to RSA in the new or in the future. There's nothing that's going to be as agile that you can do both encryption and digital signatures with. So you have to choose. So Kyber is what would kind of replace RSA encryption, and dilithium is what would replace RSA or ECC digital signatures. So that's kind of the simple story, that you, instead of one, you have to use two. That's the easiest, or the kind of first step.
So I'm seeing that in my world, kind of that we'd have two different CAs in, probably two different routes.
Yeah. You probably don't need a CA that runs Kyber, but you may want to issue certificates for end entities, or users or actual devices with Kyber keys in it.
So I could actually do Kyber off of my dilithium CA.
Exactly.
Oh,
so dilithium is used to sign the certificates to authenticate that the CA has verified that you are you, and that you have the private keys corresponding to the public keys in the certificates, and that's used with signatures, aka dilithium. Or actually, as they will be called, probably MLD DSA for dilithium and MLCAM. So I think
those names were horrible they came up with.
Yeah, I had to rehearse it in my mind before the shooting here, so I could remember to say it correctly.
I never remember those.
It's nasty.
So that's really interesting then. So I could do Kyber off of my dilithium CA. We've got kind of two worlds we're living in now, instead of where we could do RSA for jack of all trades, or we have the elliptic curve for the digital signature side. Really, I've got to go with dilithium, and I've got to go with Kyber if I'm going to do encryption. I don't have any other way.
Exactly. And then you come into kind of what's the difference with these new guys.
Yeah, so what is the difference with these new guys?
Yeah, use case we covered. So, but then when you actually want to put them into use, you have to see that there are, the key length of elliptic curve EC is remarkably small. It's so nice. But with dilithium, when you replace EC with dilithium, the keys are huge. It's orders of magnitude larger keys, which, in some cases may not differ so much. If you have a large hard drive or, fast network, you probably won't notice so much difference. But as soon as you're in some sort of constrained environment or really, really high speed that you have to, where actually, additional kilobytes over the wire
like overhead
will make
matters.
the difference.
Yeah.
Or
So
across the globe where it's higher latency, you might notice a difference. So operational environments might change. And especially, you also have to consider the size of these signatures themselves are a lot bigger.
So it could be a little bit more processing to validate those.
Yeah. And if you sign a lot of data, imagine if you sign short transactions. So you append the short signature to every short transaction. Now your signature will be larger than your transaction. And if you store kind of 1 billion of these transactions, your storage space is going to be
increase.
A lot larger. So you should probably, try out what your operation environment looks like. And are you affected by key sizes because you have limited RAM? Are you affected by digital signature sizes because you have a lot of signed transactions so that you need to store and search and things like that? So depending on what you want to do, you might be hit hard. Or if you're lucky, you won't notice any difference. So we said that we don't like to say it depends, right?
Because it definitely kind of depends in this case. And I guess that's how we could wrap up, to just say that this is why testing is going to be so important, that you go and explore these new algorithms to see how they're going to work in your environment and start gauging whether there's going to be performance issues, whether there's going to be storage issues, and getting comfortable with that to know how it's going to go. Otherwise, could be problematic, as you said. Yeah.
Because at least, check your use case. What are your limits, or where would you expect to have your bottlenecks in for a use case?
So that's the moral of the story here today on Keymasters, is get out there and test. Thank you, and we'll see you on the next episode.